Oh, let's see. Does this group want to get the Onion article for the day?
Yes.
I almost didn't read it in my class earlier. It's pretty borderline.
Give it to us.
I am recording. I did that earlier today too. So I'm giving my disclaimer. So I'm going to ask a question before I read this. Shut up. Before I read this, I'm going to ask a question.
Right.
Is anybody going to be offended by somebody being force-fed one of their own organs?
No. Go for it.
What organ?
Valid question.
All right. So here's the story. So 9 people drawn and quartered at Renaissance Fair. This is the Onion 1995, December 18th, 1995. 9 people were tore limb from limb and skewered through the anus with wooden stakes this weekend at the city's annual Renaissance Fair. Organizers boast that the drawn and quartered show made this year's fair one of the most authentic ever. You paying attention, Beaker?
Yes.
What did I just say?
Someone got skewered through the anus.
All right. Good enough. The early Renaissance torture demonstration was one of many improvisations that peppered the fairgrounds, performed by actors from the local theater community dressed in period costumes. These performances have been a fixture of past years' fairs. The skits where we publicly tortured and humiliated condemned heretics gave us by far the most response we've ever gotten, actor Paul Moline said. Who would have thought that violence would appeal to people? In the skit, victims were randomly selected from the crowd, strung up on posts, and read official charges. A dirt-encrusted dagger was then used to saw off vital parts of the condemned. One man's scrotum was cut off, causing his testicles to fall to the ground. According to witnesses, children at the festival then tossed the testicles back and forth as the victim watched. Vital organs such as the liver were cut out of further victims, then cooked and force-fed to them. The pale and barely conscious victims were then taken down from the posts and prepared for the next stage of their torture, amid taunts and bellows from the crowd. We loved it, said both University of Virginia student Steve Limberg, who along with his friend Alicia Pomfret was attending the fair for the first time. It was like we were transported back to the real Renaissance. We got turkey drumsticks at the Ye Old Grill, threw stones at the Drench a Wench booth. I won a stuffed jester doll. Then we got to see this heretic forced to eat his own kidney. Added Richmond Middle School teacher Linda Rugfuss, it was a lot of fun. They picked my husband out of the crowd and he thought it was a kick. When they eviscerated him and he started screaming and begging for his life and crying out to me, the kids and I did our part yelling, "Heretic!" and so on. Next, 4 horses were tied to the arms and legs of each victim, and each horse was made to pull in opposite directions, summarily causing limbs to tear off and go skipping in every direction. Finally, the disembodied and helpless torsos were fed to the packs of ravenous dogs. The victims' horrific wheezing screams caught the attention of the entire fair. I thought it was very impressive, said Herman Klein, an executive at a nearby bank who partook of the fair with his wife and 3 children. I enjoyed taunting the condemned, and my children enjoyed playing with the testicles. One volunteer was tied up and laid on his back, spread-eagled, his legs held apart by a short beam roped to a horse. A long wooden stake was braced against the rock and inserted just a few inches into the participant's anus. Then the horse was given a snap from the whip. It bolted, causing the participant to be driven onto the stake until it thrust out of his mouth. Festival organizer Liz Fendham has been under pressure to compete with nearby Colonial Williamsburg for tourist dollars. And she said the event was popular enough to guarantee a return next year. We try to give people a merry old time, my lord, she said with a smile. You can bet your knickers we'll be doing it again next year. She hinted they may even have the performing troupe dressed like Spanish soldiers and slaughter masses of heretic fair visitors. Though most everyone thought the fair was the most successful ever, several family members of the killed were not so enthusiastic. My husband and I came to the fair as part of our honeymoon, Jacqueline Weldon said. When he was stabbed through the heart and killed for blaspheming the Pope, the fair suddenly became less fun. Weldon added that she will not be returning next year. So, that's...
It became less fun.
See, all the good ones were from the 90s.
I know what you mean now.
actually, in looking at some of them, it's very difficult to find more modern Onion articles that are similarly of similar that are as funny, but that also contain at the very least removable profanity. Some of them now have so much profanity in there that in order for me to like edit it for recorded messaging, you would lose the entire meaning of the story. So, I guess interestingly enough. So, okay. So now that we got the stakes in the anus out of the way, that's that portion of class.
Wooden stakes.
I remember back when we used to do that portion without the onion.
Yeah, those are the good old days. Okay, so what was the homework assignment? Oh, yeah. So I need to do this inside my source reader? Oh, we need to build a tree. Oh, love this. Okay. So let's start off with that. So I'm going to create a new class. So we're going to call this guy a syntax tree.
I literally cannot read this text.
What?
I just have bad eyes.
Is that what we're going to call this? Is the syntax tree? Because we need to kind of have it play by certain rules, right?
I just call it a tree.
Called it a token tree.
Syntax, 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 syntax tree. Okay, and syntax trees hold nodes, correct? So I'll create a new class called node. All right, so for right now, what's a node? A node is a private string token, right? That's what nodes hold as tokens. The constructor for a node, public node string token. This dot token is equal to token. Okay. If I remember correctly from our algorithm dealie, we need to be able to ask whether or not a specific token is an operator, or a true statement. Debug it later, so you can pay attention to this. Well, I'm probably going to show you some ways of doing it better than you did it. All right, so we're going to create a public method, Boolean is op. That's going to return true if this guy's an operator and false otherwise. You missed a good story. What's up?
That's the worst.
I know. What was I talking about? Oh, is op. So this guy should return true if we're looking at something that contains what? Something that either looks like that or all the math ones? Okay. So what I'm going to do is I'm going to create a string array called ops, and this guy is going to be equal to the string equal the string plus minus times divide. Is that all of them? Any other operators in that? Or is that what our language supports? Okay. So for right now, we'll hard code it into there. At some point, we're probably going to want to have more of a global class that defines our operators. And, actually, we probably should do that now. Well, I set a bad precedent. So I'm going to create another class. And we're going to call this guy language reference. Good enough. And this guy is going to have a static method that returns a string array called getOps. And it's going to return this guy. Okay.
Why would we make that a separate class?
Well, because we can, that way, if we ever add an operator, we just have to do it in one location. So we're going to have one centralized place that kind of keeps track of the rules of our language. All right, so we'll have this getOps. So what will we do inside of Node here? We're going to string array called the ops, and this is going to be equal to language reference dot getOps. So notice I made that a class method. Why did I make that a class method? Is what you just said intelligent? Because you kind of mumbled it. Do you have a real answer?
No, I mean, I think it's fairly intelligent.
Okay. Well, let's actually project it.
Well, it's just like, it's easier to reference if you don't have to create an instance of it every time you're doing that, and doesn't rely on any instance members, so there's no reason for it to be an instance method, I guess.
Okay. Why doesn't it rely on it being an instance method?
Because it's consistent throughout all the instances of that object. It's something that just happens with language reference, I guess. It's just always true like this.
Okay. So if we have a variable called ops, that always is this string array. If 100% of the time it's this string array. And if we created multiple instances of language reference, it would still always be the string array. We might as well make it static so that we, first of all, don't have to create multiple instances to get at it. Like you said, it's easier to just access it through a static context, but it's more correct this way as well. We only want that variable to exist one time. And in fact, I didn't even create the variable. I could have created a class variable up here, but I would have still needed to give it a value because I wouldn't have been able to initialize it without a constructor. But in any case, every single time I call this using the class name, I will always get the same value. That's why I made it static. All right, so I went ahead and used my language reference to get the operators right here. So if any time in the future I decide to add another operator, maybe we add the modulus operator to our code, I can just go in here, make one change here, and everything else in our program should adjust. Make sense? So inside Node, what are we trying to do? We're trying to find out if token is in the ops. So we're going to say for string s in the ops, if this dot token dot equals s, that's a true statement, return true. It is an operator. Otherwise, return false after the loop. Does that make sense? So an individual node is able to tell us whether or not it is an operator or not. So a node holds a token. What else does a node hold? A node holds a private node left node and a private node right node. And inside the constructor for node, we probably want to initialize those guys to null. We do not have a left or right child until here. We'll call this left child and right child. So we'll say this dot right child is equal to null. This dot left child is equal to null. All right. Now a node knows how to tell us whether or not it's an operator. Do we care? If it's not an operator, it must be either a literal or a identifier. Okay? We don't care which of those it is, correct? We're only interested in whether or not it's an operator at this point. I'm trying to write this generically enough that as our language gets more complex, we can grow. So we probably want to have a method called, well, initially, let's say private void set left child to node n. And another one, private void set right child to node n. And for right now, we'll say this dot left child is equal to n. This dot right child is equal to n. We may come back and make these a little bit more complex or add some additional methods to handle adding children. We might add a method to ask whether or not we can add something to the left. Or we might make set left child return a Boolean and just try to add something. And if it fires back true, it got added. If it fires back false, for whatever reason, it didn't. So we'll decide when we go to actually add stuff how that needs to work. Okay, so for right now, that's our node. Syntax tree. So a tree has an initial node of root.
Soul.
He just lost a bid on the iPhones that are selling on eBay with Flappy Birds installed.
Mm-hmm.
Did you hear about these? Apparently, people are selling. There's like iPhones with like $20,000 bids on them. I'm sure it's all a fake thing. You know, that the person will say, "Oh, I'm not going to pay for this" or whatever. But there are currently things on eBay for 20 grand to buy an iPhone 5S with Flappy Birds installed. All right, so private node root. Then we'll have our constructor for our syntax tree. Public syntax tree. This guy will take in an initial node n. And we'll say this dot root is equal to n. Okay, so that's our initial syntax tree. Well, we're obviously going to be adding a node to this tree, but let's kind of write that as we come through it. So we're going to go into our source reader. And right now, what does our source reader do? All the way down here in read tokens, it prints out the lexically analyzed version of each token. Okay, which should be identifiers, literals, that kind of stuff. So what I'm going to do is I'm going to come up here and I'm going to create a private linked list of strings called token string. Okay? And in my constructor, I'll go ahead and set token stream equal to a new linked list of strings. It's going to want me to import java.util for my linked list. Okay. Now, instead of printing out all of my tokens, I want to add them to my linked list. Okay. So after read tokens is done, what do I have? I have my token stream. So I might choose to, instead of calling this read tokens, I might choose to call this guy lexical analyzer. Then in my driver, the first thing a compiler does is it calls the lexical analyzer. Okay? What does the lexical analyzer do? It goes through, reads all the tokens, adds them to a linked list called token stream. So now I'm going to need another method. Public void. What's the next step called?
Syntax analyzer.
Syntax analyzer. And this guy requires that we call lexical analyzer first. Okay, so for right now, we'll just keep them as separate things, but we might go and check, do an if statement, make sure that our token stream has something in it first, but we'll just assume it's fine right now. So syntax analyzer is going to go through and it's going to create a syntax tree, correct? So we're going to create a private syntax tree called the syntax tree. And we're going to actually give that guy a value here in syntax analyzer. So we're going to say the syntax tree is equal to a new syntax tree. And we build syntax trees by passing it the initial root node. Who's the initial root node for our tree? Go ahead. The node version of the first token. So in order to build this guy, I'm going to need to go through all my tokens. So I'll cut this line here for a second. So I'm going to say for string token in this dot token stream. For each of those tokens, we want to do something with them. So the first thing we're going to do is we're going to create a node, correct? Every single time we see a token, we're going to make a node out of it. So I'm going to say node temp up here. I'm going to say temp is equal to new node, pass it my token. So this is where our algorithm from the board comes in. All right, so first step. If I do not have a token tree, that is the syntax tree. So I'm going to start syntax tree off as null. So in my constructor, I gave my initial syntax tree a value of null, which it would have defaulted to. I just like being explicit. So down here in our syntax analyzer, I'm going to ask the question, if this dot syntax, the syntax tree, is equal to null, that is, if I have not put any nodes into my tree, I need to do that. Make sense? So what will I do? I'll say this dot the syntax tree is equal to new syntax tree, building it with temp. So if this is the first node I found, I need to build my tree and put that guy in there. Make sense? Okay. Else, if this is not the first node, I have a new node. Do I still build a node? Yep, I always build a node. And depending on what that node is, it's going to depend on what I do with it. If I'm in this else, I know that a tree already exists. That's the bare minimum I know at this point. I have a tree, it's got at least one node in it. I have no idea whether that node is, what that node is. I have no idea the current state of the tree. Okay, so I have a new node called temp here, and I need to add temp to the tree. If temp is an operator, what do I do? Build a brand new tree. So if temp is an operator, I need to build a new tree. So how do I ask if temp is an operator?
Use the language reference.
Or just use nodes isop method, which uses the language reference, right? So I'm going to ask my node, hey, are you an operator? That's the method I wrote in here. Where is it? Right down here. This guy. So that's my node. Are you an operator? If you are an operator, then I need to do some special stuff. I need to create a temporary tree. Okay, so I'm going to create a syntax tree called temp tree. And this guy is going to be a new syntax tree built with temp. Make sense? Okay, so now the next version of my algorithm says what? I need to decide, do I add this tree to my current tree, or do I add my current tree to this tree? So what am I interested in?
Adding your current tree to the temp tree.
The first tree.
I need to ask a question first. Go ahead.
First tree's root, if that root is not an operator, don't you add the old one, the new one?
Okay, so if my current tree, whose name is the syntax tree, if that guy's root node is an operator, then what do I do? If that guy's root node is an operator, then my new tree here will become what? A subtree of the current tree, right? If it's not an operator, then what will happen?
Then that becomes your
My temp tree ultimately is going to become my syntax tree. And I need to first add whatever's in my syntax tree somewhere inside my temp tree and then put it back up, right? All right, so I'm going to ask the question. Well, first of all, I need to be able to get access to the root node of my syntax tree. So I'm going to go into syntax tree. I'm going to add a method here, public node get root. And this guy's going to return this dot root. So now I can ask the question, if this dot, the syntax tree dot get root dot is op. If that's a true statement, if the root node of my syntax tree is an operator, what am I going to do?
Add it to your one child.
Not the left, it's an op.
right.
Oh,
Right.
I wouldn't be in here unless I was dealing with an operator, right?
Don't you set temp tree to the right child then?
Not yet. Go ahead.
check to see if the right child is not.
Okay.
Right. Yeah. Right.
Generally speaking, what I want to do is I need to add temp tree as a subtree of what? The right node of my current tree. It might be the immediate right. It might be that guy's right. It might be that guy's right. We don't know how far the rabbit hole goes. We just know that since it's an operator and my root node is a op, that this new subtree I just created, this guy called TempTree, will become a right subtree of the current tree at some level down. Is that an accurate statement? Okay. So, if I'm in here, we're going to add TempTree to right. Here, we'll make this creepy. The right lobe of the right branch of syntax tree. That's what we want to happen. So what I'm going to do is I'm going to go into SyntaxTree and we're going to write the logic for adding something to the right. Now, whenever we add something to the right, well, actually, I'm going to add the logic for adding an op. Add OpNode. So I'm going to say public void add OpNode node n. What are you babbling about?
It's cool.
Are you paying attention to anything I'm doing?
Well, when you said something about lobes, I was hearing that.
Did you get your compiler working? Is it going to be as slick as this one, or did you like create this monolithic procedural version of it?
No, mine's pretty.
Object-oriented, object-oriented,
That's what I was trying to say.
pwned. Where's Brandon? Isn't he in this class?
No, you let him get out of it.
Oh, he didn't. What?
You did something else, and then you didn't have to take this class. You reluctantly let him out of it.
What class is? Oh, he's in senior STEM.
Yeah.
Okay, so add OpNode. If we're adding an OpNode to a syntax tree, we know that this guy isn't going to be the root, correct? We wouldn't be calling the add OpNode to a syntax tree if this guy was supposed to be the new root node. Accurate statement? Okay. So, our first goal is to try to add this guy to the right child of root node. So, we're going to say, in order to do that, we need to build some logic into node. So here's my node class. We're going to have a public void. Actually, I think I'm going to want this to be public. No, it could be void. We don't need a real answer. Public void add op node. This guy's going to take a node n as a parameter. So this is where a recursive-like approach comes in. So this is where your experience in the 470 class will be helpful. I say recursive-like because it's not actually calling the same object, but it's calling the same method of the same type of object. So add OpNode. When we call this guy, we're going to try to set our token to OpNode, correct? Now, if I am a node, and somebody is trying to set me to an operator, that works if I am not already an operator, correct? So, if this dot is op, if I am already an operator, that's what this says. If I am an operator, then I need to pass the buck. And who do I pass the buck to? I either need to set my right child to an operator if I don't have a right child. So if this dot right child is equal to null, this dot right child is equal to n. Else, if I already have a right child, I'm going to delegate to my right child to add an OpNode. So I'll say this dot right child dot add OpNode n. So that's where the sort of kind of recursive call comes in. I'm calling the same method, but I'm not calling it on myself. I'm calling it on my right child. I'm saying, look, you've asked me to add an OpNode. I can't do it locally. It's out of my hands. I already have an operator. My right child already has something there. So I can't, it's out of my control. So I'm going to pass the buck down to my right child and say, hey, add an OpNode, and let him take it from there. Wash my hands of it. And he'll go through the same logic. That make sense? Okay, and we're hoping eventually we get to a situation where the right child is indeed null. That'll end the recursive like calls. All right, but this is I'm only going to do this if I'm currently an operator. If my token is an operator. Else, if my token is not an operator, what will I do? If somebody called me and said, hey, we want to add a operator. I'm a right node right now, correct? Whoever called me knew I was a right node and got the ball rolling with the right nodes. And if I'm looking at a node that is not an op, so if my token, my payload is not an operator, then he's only temporarily in residence. So I need to move him. Go ahead.
You'll do if this left child equals null, put it there.
Okay.
Otherwise, do the same thing and go to the next right child.
Go to the next right child. Okay.
Go down and check the next right node's left child. See if that one's empty, and if it is, then throw it there instead.
Okay. So I need to create a method called add NonOpNode. So public void add NonOpNode. This guy will take a node as a parameter. Okay, so if I'm in this else, that means that my current root node, I'm sorry, not my current node, that means that I am not an op, correct? Therefore, I need to make room for this op. So the most obvious way of doing that would be this dot token is equal to n dot. We didn't teach nodes to give us our token yet. So I'm going to swap out tokens. So let me go in. I'm already in node. So let me write a quick little method here in node. Private string get token. So I've written an accessor method, or a getter, for getting the private member token. So I'll say string temp token is equal to this dot token. Then I'll say this dot token is equal to n dot get token. Then I need to say n dot set token, which I don't think we have yet. Okay, so I need to I don't know if this is the way I want to do this. Well, it'll work. Public void set token. This dot token is equal to token. So down here we'll create a string called temp token, set it to this guy's token, then overwrite this guy's token with the token that's in n, and say n dot set token to temp token. So what did I just do? If I'm in this else, I know that this node that we're currently in, does not have a token that's an operator. Yet we're trying to add an operator. So if for whatever reason my token is not an operator, I have to move over and let the guy we're trying to add become an operator. Well, this is why this won't work. This is not going to be foolproof enough, because if we ever try to add an OpNode that is the parent of a big tree, we're just swapping out payloads. We're swapping out the tokens, where we really need to swap out the whole node. All right, so we're not going to do this. So if I'm not an operator, would that ever happen? That's the real question here. Am I solving a problem that isn't actually a problem? Will we ever put a non-operator as a write node? Sure, sure. Often. Yeah, often it would be.
Why again did you specifically add OpNode?
I was just trying to swap out their tokens. I was just saying, hey, this node already is set, good to go, but I actually don't want him to hold a non-op token. I'm going to set his token to the op token, but leave everything else structurally sound. When that really isn't what we need to do. What we need to do is build a new tree with this guy's left node. Well, actually, with this guy being that new tree's left node. And then add that new tree back into our existing tree as the guy above this. Well, I was just changing the tokens, though. We actually need to move around nodes. Does that make sense? So what I'm doing right now is this. Let's say we have something that looks like this. Well, this is good enough. So let's say that's what our current tree looked like. And we're trying to add this guy in. So we know that the root node's already an operator. So we can't put him here. So we're going to add to the right. Well, there's something already here at the right, but he's not an operator. So we really need this guy to move out of the way. Does that make sense?
Could we just add it to the that +1 temporarily? Then
Yep. So we already have a tree over here. Yeah, we already have a tree here that we just created. Did we create the tree?
in syntax, I think we did.
Yeah.
SyntaxTree.
So we might have to bounce it. We might have to bounce back to syntax. We might have to have this return a Boolean. So the situation would be this. If we have this guy sitting out here, we tried to just add him in here. And we couldn't. We couldn't add him directly. You know, if we had a situation like this, then we could have added him directly. We'll add here. This guy doesn't have room, but he'll set his right child. That would have worked.
But the stream would be incorrect then, because you can't have two operators right next to each other.
Correct. Well, but if that's what the stream looks like, that's not the syntax tree's problem.
Well,
That's the rules for creating our token stream.
I thought that's what the syntax tree was doing. Check those things, see if we.
But we're not checking them yet. We're just building the syntax tree.
Oh,
Yeah, we're not actually doing the checking at this point. But you're right. That's
checking next.
the next step. Right. So I try to add this guy here. I can't add it here because this guy, as soon as I notice that he is already taken, but he's not an operator, I know he belongs here. And since he belongs here, I actually need to bounce back out. And I need to return this node. And I need to return this node, and I need to add this node as the left node of this guy. And then I need to take this entire, I need to take this entire tree and drop it back in here. Does that make sense? That's the step we need to take. So for right now, if I'm in this, we're going to have this guy return a node. So whether we So if I could just add it as my right child, I'll just return null. Otherwise, I'll ask my right child to add it and return whatever he returns. Otherwise, right here, if I'm in the situation where I'm where it needs to get added, but I can't add it right here, I'm going to return me. Me being the node that needs to be moved. Okay?
How would that be this then?
This is a node. I'm in the node class.
Oh, no, I know that, but
So if I get inside this else, meaning that my payload is not an operator, I know that ultimately I need to add this node in place of myself. And in order to do that, I need to become the left child of this node. But then this node needs to take my place in the tree hierarchy. And I can't do that at this level. I need to go back up to the syntax tree level in order to make that swap. That make sense?
yes.
All right. So we'll stop there. We'll come back on Wednesday and finish this off.